Hello, hi everyone. Welcome to today's class. Welcome to Unacademy and welcome to Srinivasarao Sir classes. In this class, we are going to discuss the very important concept called count to infinity. So, what is a count to infinity and what is the reason to get the count to infinity? We will look at in this session. So, before entering into the session, let us all say our anthem that crack GATE and ESE with India's largest learning platform, none other than Unacademy. So get plus subscription and access unlimited live and recorded lectures from India's topmost educators. Dear friends, we all know that Unacademy has provided wonderful digital platform to serve the dedicated students by the topmost educators. Utilize this opportunity what the Unacademy is providing and enjoy the top quality content. Along with that, Unacademy is also offering a good amount of concessions. Please utilize this chance. And myself is Srinivasarao IS, having more than 15 years of experience in the GATE with the various subjects. I also had industry experience at the backend side, that is a database and the systems side, with the relevant good certifications like certified database and certified Cisco and certified Microsoft certified system and Red Hat Linux certified also. Dear friends, throughout my journey of GATE, I taught in many premium academies with a high success rate. So many of my students are completed their post graduation from India's topmost institutions like IITs, NITs, central universities, and others. And they have settled in their life just by reaching the topmost positions, either in PSU or any software companies. You also can achieve this. You also can achieve this just by clearing the prestigious competitive examination called GATE. So utilize what the Unacademy is offering, the best content, and clear your dreams because Unacademy believes that your dream is our dream is Unacademy's dream. So, my dear friends, there are two kinds of subscriptions along with this, that is a plus and iconic badge. Plus course, when you are talking, there are three kinds of subscriptions. So, use my referral code to get the subscription into Unacademy so that you're going to get a maximized a discount. So, these are the final prices after applying my referral code. If you apply my referral code, then I can be your guide. I can able to keep on guide you every day till your examination got completed. And the second kind of course is iconic batch. There are two kinds of subscriptions here. So use my referral code to get the admission into Unacademy. Then you're going to get a maximized a discount. So my referral code is eligible for every course, not only for GATE and ESE. Use my referral code and get the best content. Let's Crack GATE CSE is our YouTube channel. Subscribe our YouTube channel and use my referral code to get the admission into Unacademy. Hit the bell icon for latest notifications and updates. Here I am going to present the today's concept, that is a counter to infinity. So it is one of the typical concept which we are unable to have 100% clearance while you are getting a problem on count to infinity. So in our GATE examination, 4 times it is given. So 3 times it is based on question, 1 time it is based on a big normal 1 mark question. So here I am going to show you how you can able to do the concept of count to infinity and what are the reasons for count to infinity and how to avoid the count to infinity problems. So what is a count to infinity? So the distance vector routing is associated with the count to infinity. This is a 2 times gate question. Count to infinity, only you are going to get it from distance vector routing. And distance vector routing I already discussed. Whenever you target about the distance vector routing protocol or routing algorithm, it is going to provide accurate best optimal path, but it is not suitable for deadlines or slow transmission lines or slow processor routers. So if at all you see that your lines are active, as long as your lines are active, then it is going to provide one of the best optimal path. But in the event of any particular active line is down, then you're going to face a penalty that is nothing but writing the false delays into your routing table every time, because distance vector completely depends upon vectors distance table. Every periodical, after some kind of a time, immediately you are going to see that periodical routing tables from your neighbors. Last session I discussed that it is a 10 milliseconds. That means every periodical, after some time, you're going to see that one routing table. If at all any line is down, I'm not going to wait for that line. Immediately I will try to switch to another account. That means to reach to the destination with the help of another intermediate node. Because of this reason, you are trying to do a concept of entering into loops. A routing loops is a concept called count to infinity. And when and why it is forming a loop? Because whenever any interface is down or any active link is down or any router is failed, then immediately we are start identifying other vector tables and see that yes friend, I am covering complete syllabus only. This is my 38th lecture. Still more 20 lectures are there. Please follow all my previous lectures. So let me continue the session. So routing loops is a concept nothing but count to infinity. When are you going to get it? It occurred whenever two routers send updates to each other at the same time. This is another very important. One reason for occurrence of your count to infinity that whenever any active link is down, and another reason is that both are exchanging their routing tables at the same time and they are going to enter into what? A false delays. So writing a false cost values is a concept of count to infinity. Why it come and how to solve? Please listen carefully. It's a typical concept. So please understand carefully. So what is the main theme of your distance vector routing? The main theme of your distance vector routing is each node shares its routing tables with its immediate neighbors. Neighbors are nothing but vectors. So every 10 particular amount of time, your routing tables are exchanged by among all your neighbors. That it is going to see that whether am I get updated or not. If your neighbor sends the same table, then I am not going to update. If your neighbor sends a table which is different from my old table, which consists of less amount of delays, then immediately I will take that table and update on my table. Then I will feel that yes, I am updated. If you got a table from your neighbor which is having a different values than your current routing table, if it is lesser, I will merge with my table. If it is a greater, I don't accept it. I will just simply leave it. So in the event of less only, we are going to take those values and merge to our particular tables. So this is the point. Each node shares its routing table with its immediate neighbors. periodically and whenever there is a change. And whenever any active link is broken, then it leads to a concept of count to infinity problem. Let me show you count to infinity with two nodes. Observe carefully. I am doing count to infinity initially with two nodes. It is called as two node loop unstable. We want to see that routing tables must be stabilized, but here I am proving that routing tables are not stabilized. They are still unstable. Why? Let us see. A problem with the distance vector routing is instability. A network using a distance vector routing algorithm can become unstable. How? Let us see one example. Please observe carefully this. So there is a router 1 which is associated with A and B. There are also two other links or nodes, or you can say routers. And router 1 is integrated with your A using a line 1 or link 1, and A and B is associated with a line 2 or link 2. And the distance between or cost metric between your R1 and R2 is a 2 units, and from A to B it is a 4 unit. I already told you distance vector is offering all varieties of metric measurements like hop count, like distance, like queue length, and other one is a transmission delay. Okay, whatever may be the metric measurement, in order to find the cost of the path, here the cost is between R1 to A is a 2 and A to B it is a 4. Now observe how they are going to update their routing tables. I will show you. Listen. So between R1 to A, the cost is 2. So A is thinking that A can go to your router R1. So the cost is 2. And what is your next hop? R1. This is A's routing table. Please observe carefully. This is A's routing table to reach to your R1. Okay. Now listen. R1 and A and another node is also called as a B. So A understand that at the first iteration A can reach to the R1 using a 2 units of time. So this routing table will be updated to B. What the B is going to see that because B is not a direct neighbor to your R1, B sees that B can reach to your R1. How? B depends on its neighbor A, and from A I can able to reach to your R1. So A routing table is already shared to B, and B takes that routing table, understand that A to R1 the cost is 2. So what is a B to A value? I already gave you here. B to A value is 4. So it writes its routing table in such a way that entry in the routing table such a way that I can reach to R1 via A. Please understand, A is nothing but next hop. Via A, what is the cost? The cost is B to A, the cost is 4, and A to R1, the cost is 2. So I will write that 4 plus 2 is nothing but 6. So I am writing like this. What is the meaning of this diagram? The meaning of this diagram is nothing but A can reach to the router 1 using a cost of 2. B can reach to the router 1 using the cost of 6. Even though your R1 is not a direct neighbor to B, I am depending on my neighbor like A because A is a neighbor to your R1. So B can goes to A with a cost metric 4, and from A it is taking a 2. So my shorter path is 6. So I will recall. That's it. Your A's routing table and B's routing table are stabilized. Both are stabilized only. As long as R1 ABC are active, then no problem whatsoever. Let me write that point. What is that? As long as R1 comma A and B are active, there is no change in the routing tables. There is no change in routing tables. That means their routing tables are fixed. A's routing table is that A can reach to R1 using a 2 units, that means 2 cost, and B can reach to R1 via A using 6 units. But suddenly what happened? This is the twist. Suddenly what happened? The link between, please understand carefully from this. The link between R1 and A is down. The link between R1 and A is down. So A identified, please observe carefully. A identified that A is unable to reach. A is unable to reach to router 1. So when it is unable to reach to router 1, so R1 and A, the link between them is failed. When link between them is failed, but other link is there, because I am not talking about other link. This link is there, and here also too. Therefore, what happened? A is unable to sense the particular node because the medium is cut, or router got failed, or power of your router is gone. So because it's completely based on plug and play devices only. If there is no power, the router cannot work. Now therefore what happened? A immediately sensed that I am unable to go to R1. I am unable to go to R1. So immediately I will write, what is that? Infinity. Immediately I will write an entry called infinity. But this information do not know to the B. Please observe. After, this is the first iteration. This is the first iteration. What is the first iteration? A identified, because A is the direct neighbor to your R1. So when A tried to, it is a beaconing, A tried to beacon something from R1, R1 is not responding, then I will understand that it is a what? Something is happened. Maybe a line broken, or maybe a router is dead. Therefore, I will change my routing table. Earlier my routing table is a what? Please understand. R1 with a 2. Directly I can go to R1, but here I got a value as what? Infinity. I am unable to reach. Then in the second iteration, what happened? In the second iteration, A won't stop. Please understand. In the second iteration, A is not going to stop. What A thinks? A depends on, because a periodical table is going to come. What is a periodical table? Every particular period of time you are going to get the neighbor vector tables. So after some time you got a vector table of your B. Please understand carefully. You got a vector table of B. Therefore after some time A received B's vector table, and we understand that still B is alive. Still B is alive, that it can able to go to R1 with a cost of 6, via A. Then immediately, whenever the A receives this routing table, A start updating. Please understand. A start update. How? A thinks that I am not able to reach to R1 using a direct R1 hop. Therefore, what I am going to do? I will depend on B and I will try to go to R1. This is a foolish thing. Realistically, it is not to happen. But what the A is thinking, I am unable to go to R1 and I got a recent latest updated table of your B and it is having some metric measurement instead of infinity. So why can't I use it? A thinks that yes, I will use this value to go to your router 1. Now, in the second iteration, this is a first step. In second step, what happened? A update its routing table. A update its routing table. How it will update? Listen carefully. So once the link is down, see the first iteration. This is your first iteration I am showing you. So whenever link is down between your R1 and A, so therefore what is going to happen? A enter into infinity, but B is not disturbed. That is R3. B is not disturbed. It is X and 6 and A. This routing table will be distributed to your neighbor, that is called A. What A thinks? A start updating its table. How it updates its table? It sees that A can reach to R1. A can reach to R1 using B via B. That's the meaning of that. So how it is possible? Because B is alive to go to the R1. That is the meaning of this table. It's not infinity. Therefore, A is updating in such a way that I can go to R1 using with the help of B. What is the cost? A to B is a 4. Please observe. A to B, the cost is a 4. And B to your R1. X is nothing but router. And B to R1, already it is written as a 6. So it will write its cost as a 10. Now A's routing table is updated with this. Please see the beauty of this. Earlier I got unreached, but now I got a helpline. Helpline means what? My neighbor gave me after some time periodical update table I got. It's nothing but triggered update. I come to know that he has a chance to enter into what? A router 1. Therefore, I will use my router metric cost. So by using my line cost, my line cost is A to B is a 4 and that 4 is added to this 6 and you can able to reach to R1. But it's not possible because there is no line between your R1 and A. Okay. After some time, what will happen? After 10 units of time or 10 seconds, after some time, A shares its routing table to B. A shares its routing table with B because periodical changes now. As I updated my value from infinity to 10, immediately I got a new value. I want to inform to my neighbor that I got a new value. That is the meaning of periodical updates. Now here what happened? A shares its routing table, updated routing table with its neighbor. So see the diagram. R1, A and B. Earlier B routing table to reach to R1 is a 6 via A. And A got updated its routing table to reach to R1, not infinity, it is a 10 via B. So as I got updated, this is your second iteration. As I got updated in the first iteration, I will share this table with B. Now what will B thinks? So A's table is updated. So I need to update my table also. So what B is doing? B is updating its routing table to reach to R1. Its routing table to reach to R1 because my hop next to hop is A only. Whenever there is some change in A, I need to immediately get reflected because I am following a hop count. Therefore, whenever A gives its a new routing table, it got affected. How it got affected? Now this table is removed. Now it is writing in such a way that A to B link is live. So it takes that B can go to R1 via A with a cost metric how much? B2A is equal to 4. Please understand. B2A is equal to 4 and A to R1 is a 10. B2A is equal to 4 and A to R1 is equal to 10. That is the latest value. So it understands that 14. So it writes that 14 now. Please understand how they are writing a false values. Actually A and B cannot go to the router 1 because there is no link. But they are writing a false values. We are giving a much more burden onto the routers to do this kind of a calculations. Now you observe. Third iteration, what will happen? So in third iteration, so B table got updated in second iteration, right? So what B will, very clever, B share its routing table to its updated routing table. That's very important. It's updated routing table with A. It's updated routing table with A. Now you observe R1, A and B. Let us see the cost. The B latest cost is B can go to R1 using a 14 via A and A can go to R1 using 6 or 10, using 10 via B because I am depending on B's routing table. So A to B cost is still live for. Now B shares its updated routing table with A. So this table has come here. Now immediately A is going to update the table. So A updates its routing table with the latest values. How? A to B is equal to 4. Please understand carefully. A to B is equal to 4 and B to your R1, the value is got different value 14. So I'm going to write 18 now. This time he will remove this entry. He will add a new entry, new updated value, that is R1 18 via B. So what happened? The packet is now bouncing between A and B. A will give to B, B will give to A. Therefore, they are going. Finally, they will reach to infinity. This is the concept of count to infinity, instability among A and B. Because routing tables never stabilized. So when this guy is 18 is updated, I will share with B. Next iteration it is going to be 22. Then B will share to this guy. Next iteration it will be 26. Next A will share to B. Next iteration it will be 30. So likewise, the packet never reaches to the router 1 and it is a bouncing between A and B only. So this is the problem of what? Count to infinity. I have given example for how the two nodes are entered into count to infinity. It is called as two node problem. Two node problem. So what is our final answer? The final answer I will write. A stable and B stable. A stable initially 2. So they are writing a routing table to go to R1. That is our task. To go to R1, how they are doing? I am writing. First they are writing 2 and 6. This is the first entry. Second entry, what will happen? This guy written 10. And third entry, this is a 10, but he is writing as a 14. And fourth, he will share his table to him. It will be 18. Now he will share his table to with him. It is 22. Now he will share this table with him. It is 26 because plus 4 between the cost between them is a plus 4. Don't forget that. So this is how after 6 iterations, the value to reach to R1 is a 26 from A. The value to reach to R1 is a 22 from B. So, and it leads to finally to very large values. That is nothing but unreachable point. That is infinity. This is the concept of count to. So any doubts you can ask me. So hi Samiksha. So this is the concept of count to infinity, right? Please observe this diagram, how I shown you. So this is the first diagram for us. This is the first diagram. How those two nodes are in the routing loop. This is called a routing loop. Whenever I am talking count to infinity, it is the concept of what? The routing loop is nothing but count to infinity only. So finally, after some iterations, plus 4 and plus 4 is going to be done. Then you see that this is how the values are going to be implemented. So what is the to avoid count to infinity? Naturally, distance vector routing algorithm suffers from count to infinity whenever any active link is broken. According to our previous diagram, as long as they are live, I don't mind. Your value it is showing as a 2 to go to the R1, and the value it is going to show to go to R1 via A, because I am depending on A to go to R1. 4 plus 2, it is a 6. So as long as your router and link is active, no problem whatsoever. You can able to send your packet with a cost of 6, and he can able to send a packet with a cost of 2. But after link broken, this is the remedy. After link between R1 and A is down, and the problem start. What is the problem start? I already shown you how the iterations are going to come. First iteration, please listen again, I am writing for better understanding. I want to go to R1, but I am infinity. But this guy has a chance because he is not affected. First neighbor is going to be affected. Then in the next, what will happen? He will share this table with him. Then I will write my table to reach to R1. 4 plus 6, it is a 10 via B. I am depending on B now. This will be the same. But in third, what will happen? This table will be shared with him. Now he will update. How much it will update? 10 plus your cost metric 4. I can reach to R1 via A, via B, via A. So using 14. But this guy is fixed. In the fourth iteration, what will happen? He will share this table with him. Now he is updating R1 18 via B. But this guy is same. R1 14 via A. Now he will share this table with him. Now he will update R22A. That's it, my dear friends. Okay. So what are the remedies? Yes, there are three remedies are given. There are three remedies are given to solve count to infinity problem. The first remedy is defining infinity. That is the first remedy. How long I should go? How many iterations I should go? Is it end? Is it infinite? That we want to have a full stop there. So I am defining infinity. Is it a one iteration or a two iteration or three iteration or some nth iteration? So according to a routing information protocol RIP, which is a following your distance vector, is telling you that don't keep these many iterations because every time I'm going to update the table. You see that maximum infinity time is a 16. Please understand. Maximum infinity time is a 16. That means 0 to 15. Once 0 to 15 iterations completed, then I am saying that I am unreachable. So we want to see that I am unreachable. Right now I am reachable with the false distances, false past metrics. But I will say once after 0 to 15 got completed, both will hands up that I am unreachable to R1. Don't write any false values unless and until that link is active. When that link is active, again it start reconstructing routing tables. Right? So that is the first solution. What is the first solution? That is defining infinity. So don't say that your infinity is equal to 1. Defining infinity is nothing but I will say maximum time how much? 16, which is from 0 to 15. So after 16, then your A and B will write its value to R1 as unreachable. They will say that I am unreachable. So we are not going to put a multiple iterations. So you have to define infinity value. That infinity value can be one iteration or two iteration. But according to routing information protocol RIP, I am defining your infinity value as with 16. And the second methodology is a split origin. There are two policies in that. One is with the reverse route. The other one with what? Poisoning reverse route. Please understand. These two policies are comes under into what? Split origin. The first one, route poisoning, is nothing but defining infinity only. So what is route poisoning? I will show you. Please understand. So how you avoid node instability? How you avoid node instability among two nodes? The first methodology I am following a what? Route poisoning. Route poisoning. Also called as a what? Defining infinity. Okay. What is the route poisoning? Please understand carefully. So the guy who is the first neighbor comes to know that there is a link between the particular router and myself is down, and that guy is going to advertise to everybody in that route, everybody that I am unreachable, I am unreachable, I am unreachable. Therefore what will happen? Please understand carefully. There is a R1, there is a there is a B, and the link between this and this is lost. Link is lost. And that information, first I will understand that yes, link is lost. I am writing R1, I am unreachable. When you say that you are unreachable, immediately you spoil that route. What is the route? I am spoiling here that as I am unreachable, he will say that A is unreachable. When he says that A is unreachable to R1, and when he informs this to its neighbor, then B also will say that yes, I need to write that as my neighbor is unreachable to R, I am also cannot be unreachable as I am depending on my neighbor. Therefore, he will write that yes, I am also unreachable. So when you say that unreachable, they never be in the loop. That means A will not exchange the routing table with B and B will not exchange routing table with A. So there will not be any kind of loop between them because I spoiled the route. The spoiling route is nothing but what? Injecting poison, spreading the news that I am unreachable to the corresponding node. This is the point. So what is the route poisoning or defining infinity? I will show you. So route poisoning. When a node fails, distance vector protocol spread about this news route failure by poisoning the route. So I will inform to everyone who are my neighbors, I will inform to all my neighbors in that route that I am unreachable to so and so. So those who are depending on me to reach to that particular node, you also mark as unreachable. Don't write any false delays. Right? So route poisoning refers to the practice of advertising a route with a special value called infinity. With a special value called infinity. What is infinity value? I said according to RIP is nothing but what? 16. Exactly once you reach to 16, your packet is going to be destroyed or your packet is going to be discarded. So according to this, your RIP is kept as how much? 16. So routers considers routes advertised with an infinitic metric to say that it is a failed. So each distance vector routing protocol uses the concept of actual metric values that represents infinity. So your infinity value is nothing but 16. So this is how we try to spoil the route. We try to spoil the route that we are unreachable to the so and so node. We are unreachable to so and so node. So when you informing to every particular link, then everybody will come to know that and they are going to write their value is how much? Infinities only. To reach to your R1. Clear? So that's why distance vector protocol is not for larger networks, my dear friends. This is a very important bit which I am telling you. What is that? Distance vector routing is not for large networks. Only for small networks. Because I said that your hop count, RIP hop count is 16. So you can have 16 hops. That's the meaning of this. The second variety is a split horizon. What is a split horizon? It is a concept of like this. Let me explain with the same example. So there is a R1 and there is a and there is a B. It is 2, it is a 4. We are very happy if at all there is no link broken. But here what else? This is gone. This link is lost. Then immediately A sees that and B is trying to give you what? A routing table. I am not defining infinity here. Please observe. I am not following the first method. That is a route poisoning. I am not doing. I am doing what? Uh, B is going to share a table to me. So B is alive to reach to your R1. How much value? 6 via A. When you receive this line, please understand. When you receive this line, then R1 is updated with like this. Node A is updated to reach to R1 with a 10 via B. Then he is trying to give to this. So when you give this, again there is a loop is forming. That's why what split origin is saying, on which link you got the routing value, don't send that particular value, that particular routing table to that particular line. So reverse forwarding is not there, please understand. So actually this table has come to me from B. So A cannot able to send this table to B because you got this news from B only. That's why this is a what? A reverse route is a poisoning. What is a reverse route is poisoning? You cannot. That's what the meaning of what? Back transmission is not there. So we use a split horizon to avoid loops in the network. Information about the routing for a particular packet is never sent back. You cannot go back. It never sent back in the direction from which it is arrived. That's why, what is the meaning of that? Please understand carefully. What is the meaning? As A gives this table to B, B never advertises to A because I got this table from A only. So A is my next hop. I should not give to A once again. Likewise, B is my next hop. I should not give to B. Therefore, reverse transmission of routing table is not possible. That's why you never fall into a loop. This is not possible and this is not possible. Then both will written as a what? Infinity, unreachable point. This is one of the point called split origin. What is a split origin? You transmit your routing table in forward direction, but whatever the node is received your routing table, don't send your new route to the backside. That is not your original sender or original neighbor. So backtracking is not there in this split horizon. So split horizon can be achieved by means of technique called poison reverse. Poisoning reverse. So what is the meaning of that? Informing all routers that path back to the originating node for a particular packet as infinite metric. So they have to record as infinity. That's the meaning. So split horizon can be applied for interior routing and exterior routing. If I am using interior routing, interior routing protocol is routing information protocol. This is routing information protocol. This is one of your interior protocol. And exterior routing, I already told you all this point. It is border gateway protocol. Okay. Listen the difference between your interior gateway with a split horizon and exterior gateway with a split horizon. So split horizon for BGP. Observe this diagram. What is that? So whenever R1 sends a path to R2, that path I will not transmit to R3. Please observe carefully. Path transmission is not there. This router 2, you need to calculate a new path. Don't send the same path to him. I need to calculate a new path and send it to that particular R3. That is the meaning of BGP, split horizon rule, poisoning a route. So whenever a router receives a path and the same path will not be transferred to other router. So that router calculates a new path and send it to the other particular router. Therefore, from the below example, router 2 receives the path from router 1 and that path will not send to the router 3. So this is the concept. So therefore, what is going to happen? You try to see that your count to infinity problem is going to be solved. And this is very important. Split horizon rule with the reverse poisoning. What is reverse poisoning? Please observe carefully. Whenever a router receives a path, the same path I can forward. The same path I can forward, but reverse I cannot forward. That means what? Routing table, whatever you supplied to him, that updated routing table will not come. It goes into forward direction only. Therefore, you never see a concept of loops between your earlier router and your current router. So whenever a router receives the path, the same path will transfer to other router but never sends same path to the back. The router cannot advertise a route back how it was learned from your earlier router. So this is the concept. So R1 sends a path to R2, R2 receive a path from R1, and the path I can able to send to R3, but reverse. Whatever the table is coming from R3, I will not give to R2, and whatever the table is there with R2, I will not give to R1. Therefore, there are no loops between your routers. So there never see a concept of what? Node instability. They are stabilized only, but they goes into forward direction. This is the concept of what? Please observe carefully. This is the concept of split horizon rule with a reverse Poisson route. Okay, that's why this is using in RIP, routing information protocol. That's why I gave you that important point. Split horizon with interior gateway protocol is nothing but RIP. I will not advertise back. I will advertise forwarding direction. If you keep infinity value, that is a 16, okay, fine. Then automatically what will happen? Exactly at 16, it is going to be infinity. But it is also not going to send what? A reverse pass. Therefore, they never be in the form of what? So reverse route poisoning is nothing but we are advertising our back routers that I am unreachable, I am unreachable. This is the difference between split horizon with reverse route, split horizon with reverse poisoning route. Please observe. Split horizon with reverse route, split horizon with reverse Poisson route. Let me give you one example so that you will understand better. Split horizon with reverse route. What will happen? So there is a router 1 and there is a node A and there is a node B. The line between them is lost. So, but A and B still alive. So what will happen? This is going to give the information to B, and B can give you reverse route. Please understand, B can give you reverse route and A can give you reverse route. Reverse route is means what? I can exchange my routing path or routing table with my immediate next neighbor. That means whoever given me, I can able to give me. So that means A can send table to B for the first iteration. In the second iteration, B can, because I am next, it's back router, B can give to A. In the next time, again, this is going to be repeated. Therefore, what will happen? There will be a loop between them. So, split horizon with the reverse route is not that much efficient. Still, it is going to form a loop. So, you want to see that there will not be any kind of a loop. Remove the back path. Therefore, what will happen? R1 and A and B. So, this link is lost, we guess. But I am forwarding the path. When I am forwarding the path, this path you can forward to somebody, but don't forward the same path once again to back. We are poisoning the reverse route. That is the meaning of what? Reverse poisoning route. Okay. So reverse poisoning route, you never see any loops. But you say that reverse route, there is a chance of what? Poison. There is a chance of routing loops among nodes. So please understand those two important points. Split horizon is better utilized only with the Poisson reverse route because it is not going to form any kind of loops. So split horizon, this is a what? Whatever path you received from your previous neighbor, I cannot forward. I need to find a new path and transmit. But split horizon, internally what I am doing, I can forward the same path to others, but reverse I am not going to give you. That means what? Exchanging of your routing tables to your original sender or original transmitter. Therefore, there will not be any concept of. So router sends a path to router 2 and router 2 send the same to router 3. But router 3 and router 2 does not send a path back. Does not send the path back. This is the concept. So the use same reverse path transmission is not possible. Therefore, it avoids what? Loops. So if anybody asks you what is the difference between split horizon reverse route and split horizon with Poisson reverse route? Yes, Poisson reverse route is nothing but I have forwarded the path from A to B, but you need to inject the Poisson to next path. So this is not possible. And when you get a path from some R1 to A, you can accept it, but reverse you have to inject the Poisson. So this path is not possible. So whenever you don't have loops among your routers, there will not be any kind of loops. So no wastage of resources, avoiding routing loops efficiently, more effective than your simple split horizon. What is a simple split horizon? Split horizon with reverse route. What is a split horizon with reverse route? Let me tell you. A sends a path to B, and B also can able to share a new vector table to A. Then what will happen? I already shown you how they are going to perform iterations and write infinity value. And they also can able to send a back route. So with a back route, what is the problem? It causes wastage of resources, but also creates a problem in the form of what? Loop, and leads to congestion. So this is how you can able to avoid count to infinity problem, my dear friend. So please watch this lecture once again. Just to download it, watch this lecture once again. So finally, what we say, split horizon with Poisson reverse route. Poisoning reverse route is better to avoid count to infinity. Okay. What is a split horizon with reverse Poisson route? Whatever the path the B has received, you cannot send the same vector table to A because you learned the knowledge from A only. So this is not possible. But this is only for two nodes. Observe, my dear friends. Only for two nodes only the split horizon is going to work. But if there are three nodes who are in the loop, please observe. If there are three nodes who are in the loop, so I will tell you, split horizon with reverse Poisson route is a perfect to avoid count to infinity. Avoid count to infinity when only two nodes. That means no loop among two nodes. No doubt. But if there are three nodes, it is not at all. It is not at all perfect with three node instability. Let me show you that. Three node instability. What is a three node instability? The two node instability can be avoided using a split horizon strategy with a Poisson reverse route. But however, if the instability between three nodes cannot be solved using split horizon with a reverse route mechanism, still you are having count to infinity. So I will give you one example. See that R1, 2 is the cost, A and B, 4 is the cost, C, 3 is the cost, C, 3 is the cost. So what is the reverse poisoning? Observe, reverse poisoning means what? If B learns knowledge from A, B cannot send the table back A. We understand. And A learned the knowledge, C learned the knowledge from C. C cannot give the table back to A. But, please observe, but C can give to B, and this is a new line. It is a new line because C has not learned from A. C learned from B, and this new path I can able to spread to A, because it is not received from A. Observe carefully, it is not received from A, it is received from B, and therefore A will send back to C, and C is going to send back to B. Still there is a what? There is no use of reverse poisoning route concept here whenever there is a loop between three routers. So you cannot solve with a split horizon with a reverse route concept with a through three node concept. For example, you see this. So any doubt you can ask me. First I am writing R12A, cost is 2. So A is writing a table like I can reach to R1 using 2 metric. Next hop is R1 only. Next A with B is a 4. So B table is, please understand, B table is B can reach to R1 2 plus 4 6 via A, and third A to C it is 3. So your C table is C can reach to R1 with 2 plus 3, that is a 5 via A only. That's it. You got 3 routing tables, ABC routing tables to reach to the R1. Now you see that this link is lost. Fourth step, R1 to A link is lost. Then what will happen? Fifth step, A routing table, please observe carefully. A routing table is updated. Assume I am using split horizon with reverse poisoning route. All I am using. A routing table is updated. How it is updated? I want to go to R1. So I am unable to reach. Infinity I am getting. Unreachable. Now sixth step what? Please observe. What is the sixth step? But B can able to give you. Please see that. B is your neighbor. B can share the table with A. But it cannot. Please understand. B cannot share because this is A table, this is a B table, this is a C table. B can share the table with A, but it cannot because I am using a reverse poisoning route, because you land this table only because of A. So you cannot share it. So what is the meaning of that? B cannot share table with A. And the seventh step, C also cannot share its table with A. Please observe carefully. C cannot share table with A because I am using a reverse poisoning route. Reverse transmission of routing table is not possible. But you all know, can anybody say, I can have one alternative way? What is that alternative way? She can share, C can share routing table with B because she learned the knowledge from A, not from the B. Therefore, what will happen? She started advertising the route to B. C share routing table with B. That's it. You got disturbance. Now B got updated. How it updated? R1 earlier value, please understand how it goes. C2B is equal to 3. Please understand C2B is equal to 3 and B2 R1 is 6. So 3 plus 6, it is going to write it as 9 via C. And now at the ninth step, what will happen? Please observe carefully. Ninth step, what will happen? So ninth step, what will happen? And now B can share this table. Please understand. B can share. This is a B latest table. B can share table with A, not with the C, because you have just received from C only. Therefore, at the 10th step, A is going to be updated. A routing table is updated. So this is how they are forming a loop. A with B and C. Like this, they enter into the loop. Even though I am using a reverse poisoning, it will not helpful here. Therefore, the split horizon is not completely avoids the counter to infinity problem because of this particular reason. That's it, my dear friends. So what is a counter to infinity? Why counter to infinity will come? And what are the solutions I am using to avoid the counter to infinity? That is spoiling a route, nothing but defining infinity. And the second one, split horizon with reverse route, and a split horizon with reverse poisoning route. Thank you for sparing your valuable time. The next session we are going to learn a new important thing. All of you please join into Unacademy using my referral code for better concept, better in-depth concept, because in-depth you need to know to clear your GATE examination. Stay tuned to Unacademy and stay tuned to my classes. Thank you very much. Please share this video to all your friends so that they can able to learn, and please like and give a valuable comment so that I can able to prepare much more lectures. Thank you very much.